Welcome, dear friend, to Luminous Uplift, a quiet place where wonder and tranquility meet, and where the stories of our remarkable world are told in whispers soft enough to carry you gently towards sleep. You have found your way here after what may have been a long and tiring day, and for that we are truly glad. Set down whatever weight you have been carrying. Let your shoulders soften, let your breath slow, and allow this moment to belong entirely to you. Here at Luminous Uplift, we weave together the beauty of science and the serenity of storytelling, offering you peaceful journeys into the most extraordinary corners of our natural world. Tonight, we are diving beneath the surface of sun-warmed seas, drifting downward into the deep, cool blue where silence reigns and light dances in ribbons of silver and gold. Imagine floating weightlessly through ancient ocean waters, surrounded by the most ethereal creatures our planet has ever known. Creatures of glass and light, of rhythm and stillness, moving like living lanterns through the dark. These are the jellyfish, graceful wanderers of the deep, and their story is one of quiet wonder that has unfolded across hundreds of millions of years. If these gentle journeys bring you peace, we warmly invite you to like this video and find the subscribe button whenever it feels right. We would love for you to return whenever rest calls to you. Now, let's begin our journey into the luminous, drifting world of jellyfish. Close your eyes for a moment and let the world you know begin to soften at its edges. Let the hum of your room, the small sounds of the night, the gentle weight of where you are right now, all of it begin to drift a little further away. We are going on a journey tonight, but not the kind that asks anything of you. You do not need to hold on. You do not need to keep track. All you need to do is breathe and let the story come to you the way water comes to still places quietly from every direction at once. Tonight we are going to think about jellyfish, not the startling kind of thinking, not the bright, sharp kind that wakes you up and asks you to pay attention. No, we are going to think about them the way you might think about starlight, which is to say, with a kind of quiet awe that does not demand anything in return. Because here is the first thing you should know. The first soft and extraordinary thing, the thing that already changes how the world feels just a little bit when you really let it settle. Jellyfish are ancient. Not old the way mountains are old. Not old the way stories handed down through families are old. Jellyfish are ancient in a way that the word ancient itself struggles to carry. They are ancient in a way that reaches past language, past imagination, past almost every reference point a human mind naturally reaches for. When scientists look at the fossil record, when they brush away layers of stone that were once seafloor mud, they find traces of jellyfish that lived somewhere between 500 million and 700 million years ago. 500 million to 700 million years. Sit with that for a moment. Let those numbers float in your mind without trying too hard to grasp them. 700 million years. The Earth itself is only about 4.5 billion years old, which means jellyfish have been drifting through the world's waters for something close to 1/6 of the entire history of our planet. 1/6 of all the time there has ever been on this spinning, breathing, complicated world. If you were to compress the entire history of life on Earth into a single night of sleep, jellyfish would appear before you even reached the deepest, most restful part of your rest. They would be there in the earliest hours, long before the dreaming began in earnest. Long before things we recognize started to take shape. And this is where the vastness really starts to open up, where the story begins to feel less like history and more like something that exists outside of time entirely. Jellyfish were here before the dinosaurs. Not just a little before, not a few million years before, which is already incomprehensible. They were here hundreds of millions of years before the first dinosaur ever drew breath. When the great reptiles rose up and filled the world with their enormous presence, when the ground shook with their weight and the skies darkened with the wings of their descendants, jellyfish were already ancient. Already so old that the gap between a dinosaur and a jellyfish was wider than the gap between a dinosaur and us. Jellyfish looked at the age of dinosaurs the way we might look at something that happened last week, a brief and recent thing, measured against their own deep tenure on this earth. But even that is only the beginning of what makes these creatures so quietly astonishing. Because it is not just that jellyfish are old, it is that they have survived, they have persisted, they have passed through catastrophes so enormous that the word catastrophe feels insufficient. In the long story of life on this planet, there have been 5 great mass extinction events. 5 moments when the world as it was known essentially ended. When the skies turned dark, or the seas turned acid, or the temperatures swung so violently that most of the creatures living on Earth simply ceased to exist. The dinosaurs, for all their power and their grandeur, did not survive the last of these events. Neither did countless other creatures whose names we have only recovered from stone. Entire lineages, entire experiments in living, erased. Jellyfish survived all 5, every single one. Through the Ordovician extinction, through the Devonian, through the catastrophic end of the Permian period, when perhaps 90% of all marine species disappeared from the world entirely, through the Triassic and through the great asteroid winter that ended the age of dinosaurs, jellyfish were there on the other side. Still drifting, still pulsing, still trailing their long transparent threads through waters that had changed beyond recognition around them. There is something almost impossible to absorb in that, something that asks you to imagine a continuity so unbroken, so quietly persevering, that it makes the deepest human stories feel like brief flickers of light. We are moved by centuries. We find decades transformative. We speak of ancient civilizations with reverence. And yet all of recorded human history, every word ever written down, every city ever built, every name anyone ever carried, fits into the most recent sliver of a single % of the time that jellyfish have been alive on this earth. Some of the oldest jellyfish fossils ever found were discovered in Utah, which might seem surprising if you have not yet learned to expect the surprising from deep time. There is no ocean in Utah now. There are red desert plateaus and sandstone arches and a great salt lake that is itself a remnant of something older, a vast ancient sea that dried and contracted over millennia. But if you stand in certain places in Utah and press your hand against the right kind of stone, you are touching what was once the floor of a warm Cambrian sea. And in that stone, if you know how to look, there are impressions. Soft, circular, faint, the shapes of jellyfish that drifted through that ancient water more than 500 million years ago, and then sank when they died and were covered, slowly, grain by grain, by the sediment of the seafloor, and were held there preserved by the particular kindness of the right kind of mud and the right kind of pressure and the long, patient work of geological time. Those fossils are humbling in a very specific way. They are humbling because they are so fragile looking. Jellyfish have no bones, no shells, no hard parts at all. They are mostly water, mostly softness. To become a fossil, a creature generally needs something hard to leave behind, something that can resist the slow dissolving pressure of burial. And yet here they are, preserved in stone. These creatures that are almost nothing but water and gentle motion, found in the deserts of Utah, proof of a life so ancient it makes the stone itself feel young by comparison. This speaks to something essential about the jellyfish, something that the scientists who study them return to again and again with a kind of quiet respect. Jellyfish existed before trees. This is one of those facts that sounds like a mistake the first time you hear it, like something that has been mixed up, transposed by accident. But it is true. When jellyfish were already ancient, when they had already been drifting through the world's oceans for millions upon millions of years, there were no forests on this planet. The land was bare. There were plants beginning their long crawl onto the continents, small and low, and nothing like what we would recognize, but the great breathing forests, the tall trees with their deep roots and their canopies filtering the light, those did not exist yet. Jellyfish were here first. Jellyfish existed before fish with bones. The vertebrates, the creatures with internal skeletons, the lineage that would eventually produce fish and amphibians and reptiles and birds and mammals and us. That whole elaborate experiment was still in its earliest uncertain beginnings, when jellyfish were already a success story 500 million years in the making. Before sharks, before whales, before anything with a spine and a recognizable face, there were jellyfish. Moving through the water the way they move now, pulsing in that slow, rhythmic way, trailing their threads, going where the current took them. And this brings us to perhaps the most quietly extraordinary thing of all about these ancient creatures. Their body plan, the basic design of what they are, has remained almost unchanged for 500 million years. When a jellyfish drifts through a warm tropical ocean today, it is doing what jellyfish have always done. The shape, the pulsing bell, the trailing tentacles, the radial symmetry, the strange simplicity of a body with no brain and no bones and no blood, that design has been tested by 500 million years of change and catastrophe and transformation, and it has not needed to change. It is one of those designs that nature arrived at and then simply kept. In a world where change is constant, where evolution is always pushing and pulling at the shapes of living things, where arms become wings and scales become feathers and gills become lungs, the jellyfish has stayed. Stayed soft, stayed simple, stayed essentially itself. This is what evolutionary biologists sometimes call a successful body plan, and there is something almost philosophically interesting about recognizing that success, in the deepest biological sense, does not always mean complexity, does not always mean speed or intelligence or size or armament. Sometimes success means finding a way of being so well suited to the world that the world's changes cannot touch your essential nature. The jellyfish does not fight the current. It goes where the water goes. It does not hunt aggressively. It trails its threads and waits. It does not resist the cold or the dark or the pressure of the deep. It adjusts, softly, continuously, the way water itself adjusts to whatever shape it finds. There is a peacefulness in thinking about this, in letting yourself understand that for all the noise and urgency of the world, there is a creature that has been drifting serenely through it all since before any of the noise began. Since before language, before thought, before anything we might call witnessing or understanding, the jellyfish was already in the water, already pulsing, already doing exactly what it does now. Scientists who have studied the deep history of these animals sometimes describe a feeling that is hard to name precisely. It is something between wonder and humility, and a strange kind of comfort. The comfort of knowing that some things endure, that the world has ended and begun again, many times over. And through all of those endings and beginnings, through all of that fire and ice and darkness and slow regreening of the world, something soft and boneless and almost unimaginably simple has continued to drift through the water, continued to pulse, continued to exist. When you think about the ancient past, the truly ancient past, the kind that exists in hundreds of millions of years rather than in thousands, it can start to feel cold, inhuman, abstract in a way that distances rather than draws you in. But there is something about the jellyfish, about its softness, about the quiet grace of its movement, that keeps the deep past from feeling entirely alien. It feels instead like something you might almost recognize, like a familiar gesture in an unfamiliar language, like a voice you cannot quite place but that you know somehow you have heard before. The oceans that jellyfish first drifted through were not so different in their most essential character from the oceans of today. The chemistry has changed over geological time. The temperatures have risen and fallen. The coastlines have migrated across the globe as the continents shifted their slow, vast positions over hundreds of millions of years. But the water was still water. The darkness below the sunlit surface was still the same kind of darkness. The gentle upwelling and downwelling of currents, the rhythm of warmer water meeting colder, the slow perpetual turning of the ocean's great circulatory systems, those things were there, and in them, a jellyfish. Drifting, pulsing, perfectly, enduringly, almost impossibly itself. Let that image rest in your mind now as everything softens a little further. The ancient ocean, the unimaginable reach of time stretching backward from where you lie right now, backward through the dinosaurs and before them, backward through the first forests and before them, backward through everything that has ever lived and breathed and moved on this complicated, beautiful planet, all the way back to a sea that has no name in any language yet spoken, under a sky that holds no familiar star in any pattern a human eye will ever recognize, and somewhere in those dark primordial waters, long before the first forests had begun to breathe, a jellyfish drifted through a silence so complete that, and somewhere in those dark primordial waters, long before the first forests had begun to breathe, a jellyfish drifted through a silence so complete that even the ocean seemed to be holding its breath around it. And perhaps that is the most fitting way to begin thinking about what a jellyfish actually is. Because to understand a jellyfish, you must first be willing to let go of almost every assumption you carry about what it means to be a living thing. You must be willing to soften your grip on solidity. You must be willing to drift a little, the way the mind drifts just before sleep, when the borders between yourself and the darkness around you begin to blur and dissolve, and the world becomes less a collection of hard edges and more a gentle, continuous flow of sensation. Because a jellyfish, at its most essential, is not so very different from the water it moves through. If you were to reach your hand into the ocean and cup a jellyfish gently in your palm, you would be holding something that is by weight and by substance almost entirely the sea itself. Jellyfish bodies are composed of approximately 95 to 98% water. Think about that for a moment. As you let your body settle a little deeper into wherever you are resting right now, 95 to 98% water. The creature you're holding is barely there at all. It is more absence than presence, more ocean than animal. It is as though the sea gathered itself into a particular shape, a soft and pulsing shape, and decided for a while to move with a kind of intention before one day dispersing back into the whole. This is not a poetic exaggeration. It is simply what jellyfish are. They are creatures built from almost nothing, shaped from transparency and salt water, and a few quiet layers of biology so elegant in their simplicity that they have required almost no revision across hundreds of millions of years. Evolution, which is so often a story of accumulation, of adding complexity upon complexity, of building nervous systems and skeletal frameworks, and circulatory highways that carry warm blood from heart to fingertip, looked at the jellyfish and decided that here, at least, less was not merely enough. Less was perfect. Let us drift through the anatomy of a jellyfish the way you might drift through a half-remembered dream, moving slowly from one soft detail to the next, without urgency, without destination. Begin with what is not there. This is, perhaps, the most extraordinary place to begin with any living creature, but with jellyfish it is also the most honest. There is no brain. There is no heart. There is no skeleton, no bones, no rigid architecture of calcium and mineral to hold the body in any particular shape against the pull of gravity. There is no blood moving through any kind of vessel, no respiratory system drawing oxygen in and pushing carbon dioxide out. Nothing breathes inside a jellyfish. Nothing pumps. Nothing calcifies into hardness or permanence. The jellyfish carries none of these things, and it has never needed to. And in this way it exists in a kind of radical simplicity that is almost meditative to contemplate. We spend so much of our lives organized around systems. Our hearts beat without being asked. Our lungs expand and contract in a rhythm we rarely notice. Our bones give us shape, a story of structure, a scaffold around which everything else arranges itself. We are, in a sense, architecture. We are buildings that have learned to walk, but the jellyfish is none of these things. The jellyfish is something closer to weather, something closer to a current or a tide. It is a pattern of movement rather than a fixed construction, and when you lie very still in the dark and let your own body become a little less familiar to you, a little more abstract, you begin to understand something about why the jellyfish has always felt, to the human imagination, like a visitor from some other order of existence entirely. So what then does a jellyfish actually consist of? If we remove all the absences, all the organs and systems and structures that are simply not there, what remains? What we find is something almost impossibly elegant. The body of a jellyfish is built from 3 layers, and together these 3 layers are so simple, so economical, that describing them feels less like anatomy and more like a description of something very close to nothing at all. The outermost layer is called the epidermis. It is the skin of the jellyfish, the boundary between the animal and the ocean, though that boundary is in many ways an illusion, given how much of both the jellyfish and the ocean are made of the same fundamental substance. The epidermis is thin and permeable, a whisper of biological material stretched over the curve of the bell, and it is through this membrane that the jellyfish conducts something like breathing, absorbing dissolved oxygen directly from the surrounding water by simple diffusion. No lungs are required. No effort is made. The oxygen simply passes through, the way light passes through glass, and the jellyfish is sustained without seeming to do anything about it at all. The innermost layer is called the gastrodermis, and it lines the interior cavity of the jellyfish, the space through which food passes after it is captured by those trailing tentacles. This layer handles what you might loosely call digestion, though again, the process is so simplified, so stripped of the elaborate machinery we carry inside our own bodies, that the word feels almost too heavy for it. Food enters, is absorbed, and what remains is expelled, and the whole cycle happens in a space so small and so uncluttered that it is almost peaceful to imagine. And then, held between these two layers like the filling of something very quiet, is the mesoglea. This is the jelly. This is the substance that gives the jellyfish its name, its character, its dreamlike quality. Mesoglea is a translucent gel-like material, mostly water, held together by a loose network of proteins and scattered cells, and it makes up the vast majority of the jellyfish's body mass. It is neither muscle nor organ. It is not doing anything in the way that we usually understand biological material to be doing things. It is simply there, giving the jellyfish its shape, its buoyancy, its quality of being somehow both present and absent at the same time. When you watch a jellyfish moving through the water, the bell pulsing gently open and closed in that slow, rhythmic way, much of what you are watching is mesoglea. You are watching water, held in the shape of a living thing, moving through more water, and the distinction between the creature and its environment is so subtle that it begins to feel almost philosophical. Now, you might be wondering if there is no brain, if there is no central command, no neural headquarters issuing instructions down long corridors of nerve fiber, then how does a jellyfish do anything at all? How does it pulse? How does it respond to light or to the presence of something worth capturing? How does it know, in any sense of the word, what is happening around it? This is one of the most quietly astonishing things about jellyfish biology, and I want you to hold it gently, the way you might hold a very small, very delicate piece of something beautiful. Jellyfish do not have a brain, but they are not without sensation. Spread across the entire surface of a jellyfish's body is something called a nerve net. It is exactly what it sounds like, a diffuse, distributed web of simple nerve cells that covers the jellyfish like a soft mesh, with no center, no hierarchy, no single point of coordination. When something touches one part of this net, a signal moves outward from that point like ripples on still water, spreading across the body and triggering a response. The whole animal is, in a sense, the brain, or perhaps more accurately, there is no brain, and yet the animal still responds, still moves, still navigates its world with a quiet effectiveness that has kept it alive across an almost unimaginable span of geological time. There is something deeply restful about this idea, once you let it settle. We are so accustomed to thinking of intelligence, of awareness, of response to the world as something that requires centralization, something that requires a headquarters, a commander, a place where all the information arrives and all the decisions are made. The jellyfish offers a gentle alternative. What if awareness could be distributed? What if sensing and responding did not require a center at all? What if it could simply be everywhere at once, soft and present and spread across the whole surface of a being, like light on water? And there is more, even within this simplicity. Around the edge of the jellyfish's bell, tucked between the scalloped margins like tiny secrets, are small structures called ropalia. They are, in terms of their visual complexity, not much to look at. They are small club-shaped sensory organs, and most species of jellyfish have several of them arranged at regular intervals around the bell's circumference. But within each ropalium is a collection of sensory capabilities that allow the jellyfish to orient itself within the ocean in ways that matter deeply to its survival. Some ropalia contain what are called statocysts, tiny chambers filled with fluid and containing small mineral crystals that shift in response to gravity. When the jellyfish tilts, the crystals move, and the statocyst registers the change and sends a signal through the nerve net. This is how a jellyfish knows which way is up. Not through any conscious deliberation, not through a brain weighing the evidence and making a judgment, but through these small, exquisite gravity-sensitive rooms at the edges of its bell, each one a tiny oracle of orientation. Other Ropalia contain simple, light-sensitive structures, primitive eyes in the loosest sense of the word, that can distinguish between light and darkness, between the bright shallows and the deeper, dimmer water below. Some species of box jellyfish have Ropalia with eyes so developed they contain a cornea, a lens, and a retina, though what precisely these animals do with the images those eyes might form, in the absence of any brain to interpret them, remains one of those beautiful unresolved mysteries that science carries with it like a lantern into the dark. But for most jellyfish, the Ropalia are simply the edges of awareness. They are the animal's most outward-facing senses, its lightest contact with the world, and they feed their quiet signals into the nerve net that spreads across the whole of the body. And somewhere in that diffuse and decentralized web, a response takes shape. The bell pulses, the tentacles trail. The jellyfish moves, or does not move, in some direction that suits its survival, without ever knowing in any way we would recognize as knowing that it has done so. There is a quality to all of this that I find enormously soothing, lying with it at the end of a long day, when the mind is finally beginning to soften at its edges. The jellyfish asks nothing of itself that requires urgency. It asks nothing of itself that requires a center, a plan, a narrative of cause and effect running from past to future. It simply exists in each moment as a responsive surface, a soft and open and almost perfectly transparent presence in the water, sensing what is there to be sensed, moving in response to what is there to be moved by, and releasing everything else. The bell opens, the bell closes, open, closed, open, and in that rhythm, which is not quite the rhythm of breathing, and not quite the rhythm of a heartbeat, but which holds something of both, the jellyfish moves through its world as though the very concept of effort had never occurred to it, as though the water and the creature were collaborating in something wordless and unhurried, something that has been going on for so long that it has become indistinguishable from the nature of the ocean itself. When you think about the fact that these animals are made of almost nothing, that they contain no hard structures, that even a large jellyfish beached on the sand will vanish within hours, evaporating back into the moisture of the air, leaving almost no trace of having existed at all, there is something in that not just sad, but strangely liberating. The jellyfish does not accumulate. It does not fossilize easily. It does not leave monuments. It moves through the world, and then it becomes the world again, and the boundary between having been alive and having been the sea is, in the end, barely a boundary at all. And perhaps that is why we find them so mesmerizing, so hypnotic, when we watch them moving in an aquarium or filmed in slow motion against the blue darkness of open ocean. They remind us of something we know but rarely feel. They remind us that most of what we are is also water, that the borders of the self are softer than they seem, that the solidity we feel, lying here in the dark, is real but not the whole story, and that somewhere beneath the weight of bones and breath and the hum of a nervous system that never quite stops working, there is something quieter, something more diffuse, something that does not require a center to be present in the world. The jellyfish carries this knowledge in every layer of its simple luminous body, in the epidermis that barely separates it from the sea, in the mesoglea that is more dream than substance, in the nerve net that knows without thinking, that responds without deciding, in the Ropalia that read light and gravity at the edges of awareness, like small poems written at the margins of a larger silence. And so it drifts, as it has always drifted, through water that is nearly identical to itself, through darkness and through light, through cold and through warmth, pulsing its quiet pulse, trailing its soft threads behind it, asking nothing more of the universe than that it be allowed to continue being this particular, temporary, transparent arrangement of seawater and sensation. It is almost impossible not to wonder what it might feel like to exist as something so transparent, so unburdened by solidity, moving through the world as though you yourself were made of it. It is almost impossible not to wonder what it might feel like to exist as something so transparent, so unburdened by solidity, moving through the world as though you yourself were made of light and water and the soft, dark space between stars. To move not with effort, not with the grinding mechanical push of limbs and leverage, but with something far older and far more gentle. Something that feels less like motion and more like breathing. And this, perhaps more than anything else, is what draws us so completely into the world of the jellyfish. Not just what they are, but how they move. Because there is something in their movement that speaks to a part of us we rarely get to visit anymore. The part that remembers what it felt like before we understood urgency, before we learned the language of rushing and striving and pushing against the current. The jellyfish does not push against anything. The jellyfish simply pulses, and in that pulsing finds a way through the water that is so quiet, so impossibly efficient, that scientists who have spent years studying locomotion still find themselves a little astonished by it. Let us imagine for a moment that you are somewhere warm and soft, perhaps lying in the dark with the sound of water nearby, real or remembered. And in your mind, drifting slowly into view, comes a jellyfish. A moon jelly, let us say, pale and luminous as a full moon seen through fog. It drifts at first, simply suspended in the middle distance of your imagination, its bell gently open, its trailing arms and tentacles hanging below it like the softest possible curtains in the lightest possible breeze. And then, slowly, it begins to move. What you would notice first is the rhythm. It is so unhurried that at first it barely seems like motion at all. The bell, that wide and rounded dome of translucent tissue, draws gently inward, just slightly, just enough, and then it opens again, releasing, relaxing, spreading back to its full soft width. And then again, inward, outward, a pulse, a breath, a heartbeat that is not quite a heartbeat but feels like one, feels like the most fundamental kind of rhythm there is, the kind that exists before language, before thought, before the complicated machinery of being a creature with bones and intentions. This is how a jellyfish moves. By contracting its bell, by drawing that circular dome of muscle inward in a smooth and gentle squeeze, it pushes water backward and behind itself, and in doing so, nudges itself forward. This is jet propulsion, but jet propulsion stripped of all its associations with speed and force and the roar of engines. The jellyfish's version is whisper quiet. It is jet propulsion as lullaby. The mechanics are real and precise and have been studied carefully by researchers who wanted to understand not just how jellyfish move, but why they move so extraordinarily well, why they have been so successful at this particular way of being in the world for longer than almost anything else we know. The bell contracts, water is expelled, the jellyfish moves forward, and here is where it becomes remarkable. Here is where the science slips into something that feels almost like magic. Because the jellyfish does not simply push water and then wait. It recaptures something from that water. As the expelled water moves behind the jellyfish, it creates a kind of swirling pocket of motion, a vortex, a gentle spinning of water that the jellyfish can then use as it relaxes its bell back open. The opening bell draws on that swirling water, uses the energy already present in it, pulls itself forward again, not entirely through its own muscular effort, but partly through the momentum it has already set in motion. Scientists call this passive energy recapture, and it is one of the most elegant solutions to the problem of movement that evolution has ever produced. Think of it this way. Think of what it would be like to swing on a swing, and instead of having to pump your legs every single time to keep going, the air itself, disturbed by your previous arc, gave you a little pushback, as though the world remembered your last movement and offered it back to you, gently, freely. The jellyfish lives inside that kind of generosity. It gives a little energy to the water, and the water gives some of it back. And because of this beautiful reciprocal relationship between the jellyfish's body and the fluid world it moves through, jellyfish have been found to use up to 48% less energy than almost any other swimming animal of comparable size. 48%. That is not a small margin. That is not a modest efficiency. That is the kind of number that makes biologists and engineers lean forward in their chairs and start reaching for pencils, because there are things being done here that we are still trying fully to understand. And yet the jellyfish arrived at this solution not through design or deliberation, but through something far more patient. Through millions upon millions of years of simply being, of drifting and pulsing and surviving, of finding the shape and the rhythm that fit most perfectly into the physics of water. Evolution, in this case, did something extraordinary. It found an answer to the question of efficient locomotion that our own engineering is only now beginning to approach, and it found it in a creature with no brain, no spine, no centralized nervous system of any complexity whatsoever. The jellyfish did not think its way to this solution. It simply became it. Running in a ring around the margin of the jellyfish's bell, arranged in a neat and almost mathematical circle, are specialized muscle cells. These are the cells responsible for that pulsing rhythm. These are the quiet architects of all that graceful movement. They are not directed by a brain. There is no central command, no decision being made in any familiar sense of the word. Instead, these cells fire in a coordinated wave, a ripple of contraction that moves smoothly around and across the bell, drawing it inward in that soft and regular squeeze. The whole system is beautifully distributed. The rhythm arises not from any single point, but from the collective coordination of many small signals, each one following from the last, the way a wave moves through water, not because any one water molecule is traveling the length of the ocean, but because each one nudges the next, and the next nudges the one after that, and the motion passes through as though it were a single living thing. It is this distributed, rhythmic quality that gives jellyfish movement its hypnotic character. When you watch a jellyfish pulse, you're watching something that has more in common with a wave than with a walk. You are watching physics made organic, made gentle, made slow. The rhythm does not vary much. It does not speed up with anxiety or slow down with hesitation. It is simply there, steady and patient, the same contraction following the same relaxation following the same contraction, like a clock that keeps time in the language of water rather than the language of gears. Now, jellyfish are capable of directed movement. They can, when they choose, swim upward. They have been observed ascending toward the surface of the water, often following gradients of light or the faint chemical traces of food, moving with purpose, moving deliberately, one slow pulse at a time. They are not entirely at the mercy of the sea, but their purposeful locomotion is largely vertical, largely a matter of up and down, of rising toward something or sinking gently away from it. The horizontal world, the vast lateral expanse of the ocean that belongs mostly to the currents. The jellyfish surrenders that dimension to forces larger than itself, and in doing so travels the world in a way that requires almost nothing from it, drifting across entire ocean basins carried by water that has its own ancient direction, its own slow and planetary momentum. There is something profoundly restful in this idea, that an animal can participate in the world simply by being in it, by floating within it, by allowing the great slow movements of the ocean to carry it from one place to another, while it attends only to the small intimate business of pulsing, of rising, of simply persisting. It does not plan its journey. It does not navigate. It is navigated. And in exchange for this surrender, it receives the whole world, or at least as much of it as the currents care to offer. We have a name in the study of ocean biology for animals that live this way. We call them plankton, which comes from a Greek word meaning wanderer or drifter. The jellyfish is, in this technical sense, a form of plankton, or at least it travels partly in the plankton's company, carried by the same currents that carry microscopic algae and the eggs of fish and the larvae of creatures that have not yet decided what they will become. To be plankton is not to be small or insignificant. To be plankton is simply to have chosen, or to have been shaped by evolution to choose, participation over resistance. It is to say to the ocean, I trust you. Take me where you are going. And the ocean takes them. Through warm equatorial waters and cool upwellings, through depths of brilliant blue and depths of velvet black, through seasons and through decades, jellyfish drift and pulse and drift again, their bells gathering and releasing, their bodies asking so little of the physics around them and receiving in return such enormous gifts of free passage. When researchers first began to study the energetics of jellyfish locomotion in any serious way, there was a sense of genuine surprise at what they found. The expectations we bring to the study of animal movement are shaped largely by our familiarity with vertebrates, with creatures whose locomotion is expensive, whose muscles burn fuel at significant rates, whose efficiency is always a compromise between speed and cost. We think of swimming in terms of the streamlined muscle of a tuna or the powerful stroke of a dolphin. And these are indeed impressive, elegant in their own way. But jellyfish operate in a different economy entirely. The numbers that came back from studies of their energy consumption were so low that they had to be checked and rechecked. And still they held 48% less energy than comparable swimmers. Still moving, still going somewhere, still pulsing. The secret, as we have already touched on, is that passive energy recapture, that beautiful recycling of motion. But there is more to it than that alone. The shape of the jellyfish bell, the softness of the tissue, the way the entire body deforms and recovers with each contraction, all of it is contributing to a kind of hydrodynamic harmony that we are still working to fully describe. The jellyfish does not cut through the water so much as it collaborates with it. It negotiates. It offers the water a shape that the water finds agreeable, and the water in return offers the jellyfish a passage. Lie still now. If you are still, let yourself feel, or imagine you feel, the weight of water around you. Not oppressive water, not cold or dark water, but warm and gentle water, the kind that holds you rather than resists you. And imagine your breath as a kind of pulse. Inhale and your chest expands. The bell opens, the relaxation spreads outward from your center. Exhale, and the gentle contraction comes, soft and slow. The quiet squeeze that moves something, that shifts the world just slightly, that sends you drifting in some direction you did not need to choose. And the water swirls behind you, warm and generous, and before the next breath even begins, the water is already giving back some of what you gave it, already reaching forward to help you on your way. This is what the jellyfish knows. This is the rhythm it has been living for more than 500 million years. Not fast, not forceful, not dramatic in any conventional sense, but so perfectly adapted to its element, so deeply in conversation with the physics of the world it inhabits, that it moves through life spending almost nothing and receiving almost everything. The bell contracts, the bell expands, the water spins gently in the wake, and somewhere in the deep column of the ocean, lit from above by a diffusion of pale green light, or below by the cold blue sparks of bioluminescence, a jellyfish pulses. Once and again, each contraction sending soft ripples outward into the dark water, a rhythm as old as the ocean itself, steady and unhurried as the breath of someone already beginning to each contraction, sending soft ripples outward into the dark water, a rhythm as old as the ocean itself, steady and unhurried as the breath of someone already beginning to drift toward sleep, toward that soft country where the edges of things grow gentle and indistinct, where one thought dissolves into the next, the way ink dissolves in water, slowly, beautifully, without resistance. And it is in that dissolving, in that gentle letting go of definition, that we find ourselves drawn downward now, following the pull of curiosity the way water follows the pull of depth, descending through layers of ocean that grow quieter and quieter the further we go, the surface light fading above us like a memory of afternoon, becoming diffuse, becoming blue, becoming the faintest suggestion of illumination before it disappears entirely, leaving us in a darkness so complete and so absolute that it seems almost to have texture, almost to have weight, as though the dark itself were a substance you could hold in your hands, cool and smooth as river stone. But here is the extraordinary thing about this darkness, the thing that makes it unlike any darkness you have ever encountered above the surface of the sea. This darkness is not empty. This darkness is not still. This darkness is, in its own quiet and astonishing way, filled with light. Not the light of sun or moon, or the distant cold glitter of stars. Not any light that was ever borrowed or reflected or carried from somewhere else. This is light that belongs entirely to the creatures who make it. Light born from chemistry and patience, from the slow and intricate conversation between molecules deep within living tissue, light that arises from within the body itself, the way a dream arises from within the mind, quietly, without announcement, simply there when you turn your attention toward it. We call it bioluminescence, and it is one of the oldest and most widespread phenomena in the natural world, though most of us will never witness it except in the occasional magical flicker of a firefly against a summer evening, that brief bright comma of light that punctuates the warm dark air of a July night and makes children run toward it with cupped hands and held breath. But that familiar domestic wonder is only the most visible edge of something vast, something that extends through oceans we will never see and into depths we can barely imagine. A living glow that suffuses the deep water, the way certain old buildings seem to hold the warmth of the people who have moved through them. Something residual, something essential, something that has been happening for so long it has become simply the nature of things. Down here in the deep ocean where sunlight never reaches, where the world above is as remote and theoretical as another planet, nearly 76% of all living creatures produce some form of bioluminescence. Let that number rest in your mind for a moment, the way you might let a stone rest in your palm, feeling its weight and its smoothness before you understand it fully. 76%. More than 3/4 of all life in these lightless depths carries light within itself, flickers with it, pulses with it, uses it to speak and to hide and to hunt and to warn, a whole civilization of cold fire conducting its ancient business in the dark. And among all the creatures that carry this living light, there is something particularly tender and strange about the jellyfish, those boneless, brainless, breathtaking animals who have been doing this longer than almost anything else alive, who were glowing in dark water before the first fish ever opened its eyes, before the first tentative creature pulled itself onto land and felt the shocking warmth of sunlight on its skin for the very first time. The jellyfish were here then, and they were glowing, and in some form or another they are glowing still, in their unhurried, unassuming way, tending their small interior fires with a patience that borders on the eternal. The light itself is born from chemistry, from a reaction that takes place within the jellyfish's body involving special proteins called luciferins, a name that sounds almost mythological, almost like something from a story told around a fire, which is perhaps fitting given that these proteins are, in their own microscopic way, the fire itself. When oxygen encounters luciferin in the presence of certain enzymes, a reaction occurs. Electrons become excited, they rise to a higher energy state, and when they fall back to where they belong, they release that borrowed energy, not as heat, but as light, a photon of pure cold illumination that travels outward through translucent tissue and into the surrounding water and beyond. The whole process happens without warmth, without combustion, without any of the hungry consuming quality that we normally associate with light making. This is why bioluminescence is sometimes called cold light, because it is light that costs the creature almost nothing in thermal terms. Light that does not burn the hand that makes it. Light that is somehow both a product of chemical energy and a thing apart from the usual bargain between energy and heat that governs so much of the physical world. There is something deeply restful about that idea, isn't there? Light that does not burn. Illumination without cost or consequence, without the consuming urgency of fire. It asks nothing of its surroundings. It simply is. Some jellyfish flash or pulse their light in response to touch, in response to disturbance, the way a startled person might exclaim before they have even registered what surprised them, a reflexive brightness, an involuntary flare. Scientists believe this may serve to startle predators, a sudden burst of cold fire in the dark water meant to confuse or frighten whatever has come too close, or perhaps to summon a larger predator toward the thing that disturbed the jellyfish, a kind of luminous alarm that rings through the dark ocean the way a bell rings through fog, clear and strange and carrying further than you might expect. Imagine being a small fish in absolute darkness, and suddenly the creature you approached erupts in light, not warmth, not sound, only this cold, brilliant pulse radiating outward in all directions. The darkness shattered for just a moment before it closes back in again, complete and quiet. Whether it frightens predators is something we are still learning, still listening for, in the patient way that science listens, attentively, without assumption, willing to be surprised. But not all jellyfish light is sudden or defensive. Some of it is simply present, a steady, soft radiance that suffuses the body of the animal the way late afternoon light suffuses a room with thin curtains, diffused and gentle and everywhere at once, not pointing at anything in particular, not doing anything that can be easily named, simply illuminating the space it occupies with a quality of presence that is almost contemplative. And then there is a jellyfish that changed the world, quietly, without fanfare, simply by doing what it had always done in its cold northern waters, glowing its soft green glow in the dark, carrying within itself a molecule that human beings would eventually discover and use to illuminate the inner workings of life itself. Her name, if we can speak of a jellyfish having a name, is Aquaria Victoria, the crystal jellyfish, and she is found in the cool Pacific waters off the coast of North America, a translucent bell-shaped animal perhaps a few inches across, nearly invisible in the water, a ghost of a creature, more absence than presence, the kind of thing you might look directly at and not quite see. But she carries within the edges of her bell a substance, a protein, that produces a green fluorescent glow when it is stimulated, a color so specific and so vivid that it seems almost deliberate, almost like a choice, as though the jellyfish had considered all the colors available to her and selected this one particular shade of living green with some private purpose in mind. Scientists first noticed this protein decades ago, but it was in the 1990s that researchers began to understand what it might mean for biology. This green fluorescent protein, which is known simply by its initials GFP in the language of laboratories, turned out to be one of the most useful tools in the history of biomedical science. Because of its particular chemistry, GFP can be attached to other proteins, other genes, other cellular structures, and when it does so, it tags them with that distinctive green glow, making them visible under fluorescent light, allowing scientists to watch living cells in real time, to follow the movement of individual molecules through the interior landscape of a living organism, to see for the first time the intimate private activities of cells doing their quiet essential work. Before GFP, watching what happened inside living cells in real time was extraordinarily difficult, a matter of inference and approximation and educated guessing. After GFP, biologists could observe the dance directly, could watch cancer cells moving and dividing, could follow the signals that nerves use to speak to one another, could see developmental processes unfolding in real time, the way you might watch time-lapse footage of a flower opening. Suddenly the invisible made visible, suddenly the dark interior of life itself illuminated by a light that had been glowing, patiently and without expectation, in cold Pacific water for millions of years before anyone thought to look for it. In 2008, the Nobel Prize in Chemistry was awarded to the scientists who discovered and developed green fluorescent protein as a tool, a recognition from the highest levels of human intellectual achievement that a jellyfish, a boneless, translucent creature without brain or bone or any of the apparatus we normally associate with importance, had given us something genuinely transformative, a light to see by in the deepest darkness of biology. The jellyfish, needless to say, was not present at the ceremony. She was elsewhere doing what she had always done, pulsing slowly through cold water, glowing gently, attending to no business but her own. There is a quality of humility in that which I find very beautiful. The way this creature simply went on being itself, simply continued to make its cold green light in the same water where it had always made it, while far away in laboratories human beings gradually understood what that light was and what it might offer, and eventually gave it their highest honor, which the jellyfish did not require and would not have recognized and did not need in any way. Having already received the only recognition that matters, which is simply to exist to continue to glow. The light of bioluminescence carries no warmth, as we have said, no heat to betray its presence in the thermal darkness of the deep sea, and this too seems right, seems fitting, seems consistent with the particular character of these creatures who have been doing this since before the continents settled into their current shapes, since before the mountains rose and the great rivers cut their slow paths to the sea. There is a kind of wisdom in light that does not consume, in brightness that asks nothing from its surroundings, in illumination that arises from within and spreads outward freely, without agenda, without urgency, simply because the chemistry of being alive in this particular body, at this particular depth in this particular ocean, gives rise to it, the way certain mornings simply give rise to mist. Not because the morning intends it, but because the conditions are exactly what they are, and could not be otherwise. You can imagine them, if you let your mind go quiet enough to do so, drifting in that absolute darkness like scattered embers from a fire that burned somewhere impossibly far above, each one a soft and self-contained universe of cold fire, each one asking nothing of the darkness except permission to move through it, each one carrying its light the way you carry the particular quality of your own mind, not as a possession, not as an achievement, but simply as the outward expression of what you are, as natural and unremarkable as breathing, as steady as a pulse. Some of them flash, some of them glow with that even, continuous light. Some pulse in rhythms that seem almost deliberate, almost musical, the way a distant lighthouse pulses not urgently but steadily, marking its presence in the dark, not with alarm, but with simple, reliable truth. Here, here, still here, and the deep ocean holds them all. The flashers and the glowers and the gentle pulsars, holds them in its cold and lightless volume the way sleep holds the mind, surrounding and supporting and asking nothing back, receiving whatever light is offered without preference or judgment, equally dark everywhere, equally ready to carry the small traveling flames of these ancient animals wherever their slow contractions take them. The thought of it, if you allow it to settle into you the way warm water settles into tired muscles, is not frightening but deeply peaceful, not lonely but quietly companionate, an entire world of living light conducting its patient and ancient business in the dark, unobserved by almost everything, requiring nothing from the surface and nothing from the sun, entirely sufficient in their cold illumination, entirely themselves. And far below the reach of any sunlight, in water so deep and so dark that pressure itself becomes a kind of presence, these small living lanterns continue to glow with a light that asks nothing of the and far below the reach of any sunlight, in water so deep and so dark that pressure itself becomes a kind of presence. These small living lanterns continue to glow with a light that asks nothing of the world around them, seeking no audience, requiring no witness, simply existing in the way that ancient things exist, completely, quietly, without apology. And it is this quality, perhaps this utter self-containment, that makes the jellyfish such a strange and tender subject for wonder. Because when you look closely, and I mean very closely, closer than the eye alone can travel, you begin to find that the jellyfish is not merely a drifting bell of soft light. It is an architecture of astonishments. It is a collection of miracles so small that we nearly miss them entirely, and only the patient work of scientists peering through microscopes and slowing down time with high-speed cameras allowed us to glimpse what had always been there, firing away in the dark water, too fast for ordinary perception, too extraordinary for easy belief. Let us drift then toward one of those astonishments. Let us move gently and without hurry toward the edge of a jellyfish tentacle that long trailing ribbon of tissue that hangs beneath the bell like a curtain stirred by an underwater breeze. To the naked eye, this tentacle might seem simple. It is translucent, almost invisible, a thread of living glass suspended in the blue. You might not think, looking at it, that it contains anything remarkable at all. You might not imagine that something is waiting inside it. But something is always waiting, in the way that all small and precise things wait, with a stillness that is not emptiness, with a readiness that is not tension, but something closer to perfection held in suspension, like a breath not yet taken, like a word not yet spoken, hovering in the space just before. The outer surface of a jellyfish tentacle is covered almost entirely with specialized cells. These cells are called cnidocytes, a name that comes from the ancient Greek word for nettle, that small and unassuming plant that taught so many of us in childhood the surprising lesson that very small things can make themselves known with remarkable clarity. Cnidocytes are the stinging cells of the jellyfish, and they are found not only in jellyfish, but in all members of the phylum Cnidaria, that ancient and diverse group that includes sea anemones and corals, and the delicate Portuguese man-of-war with its vivid purple float. These cells are, in a sense, the defining feature of the entire group, the thing that unites all these different creatures across hundreds of millions of years of separate evolution, this one elegant and devastating invention that the ocean seems to have decided very early on was worth keeping. Inside each cnidocyte, nested within the cell like a letter folded inside an envelope, there is a structure called a nematocyst. And here is where the story becomes quietly extraordinary. A nematocyst is, at its heart, a tiny capsule, a pressurized vessel of almost incomprehensible delicacy. Within this capsule, coiled tightly and with extraordinary precision, is a hollow tubule, sometimes barbed, sometimes smooth, sometimes coated with venom, always spring-loaded with a potential energy that seems almost impossible given how small it is. This coiled tubule is often described as a harpoon, and that is not a bad analogy, because like a harpoon, it is designed to travel fast and to penetrate, to deliver something from one place to another with speed and certainty. But even the word harpoon, with all its connotations of size and force and human intention, cannot quite capture the particular quality of the nematocyst, because the nematocyst is something else. It is something quieter and more ancient than anything we have built. It is a tool refined over 600 million years, and it works with a perfection that no engineer has yet been able to fully replicate or surpass. When a trigger is activated, and this trigger can be a chemical signal, a touch, a vibration in the water, a change in pressure, sometimes simply the presence of certain compounds released by passing prey, the nematocyst fires. And the word fires is exactly right, because what happens next is an event of almost violent suddenness embedded within something that otherwise moves so slowly, so dreamily, so far from anything we would associate with speed or urgency. The capsule opens. The pressure inside it, built up through osmotic forces over a long and patient preparation, is released, and the coiled tubule shoots outward, inverting as it travels in the way that a glove finger turns inside out when pulled, extending from naught to its full length in a time that is almost impossible to hold in the mind. A nematocyst can fire in as little as 700 nanoseconds. 700 nanoseconds. Let us stay with that number for a moment, because numbers like this deserve to be slowed down and examined, the way you might hold a very small and perfect thing up to a light to see it better. A nanosecond is 1/billionth of a second, and a nematocyst can fire in 700 of them. This makes the discharge of a nematocyst one of the fastest biological processes ever recorded anywhere in the living world. Faster than a nerve impulse. Faster than the blink of an eye by orders of magnitude so large they begin to feel like a different kind of reality altogether. When scientists first captured this firing on high-speed cameras, slowing it down until they could see each fraction of the event, they described their reactions in terms that scientists do not often use, terms of astonishment, of disbelief, of something approaching awe. Here was this tiny cell, this microscopic capsule no larger than a grain of pollen, doing something that nothing else in all of biology did quite so fast or quite so perfectly. Here was the ocean's oldest trick, still working, still dazzling, still as effective as it had been when the first soft creatures trailed their tentacles through a world without fish or whales or any creature yet capable of being impressed. And the speed is only part of it. When a nematocyst fires, it generates an acceleration of approximately 5,410,000 times the force of gravity. 5,410,000 g. For comparison, a fighter jet pulling a tight turn might subject its pilot to 9 g, and this is enough to cause a loss of consciousness. A bullet leaving a gun barrel experiences perhaps 100,000 g. The nematocyst exceeds this. The nematocyst exceeds virtually every other known biological mechanism in the forces it generates during discharge. It is, in the most precise and literal sense, the most powerful biological accelerator we have ever found. And it is invisible to the naked eye. It lives in the trailing edge of a translucent ribbon of tissue drifting through the ocean with complete indifference to the records it is breaking, the limits it is exceeding, the quiet revolution of physics it contains within each microscopic cell. When the tubule strikes its target, a small shrimp, perhaps, or a fish larva, or the soft skin of a passing creature, it penetrates. If it carries venom, that venom is delivered directly through the hollow channel of the tubule, entering the prey almost instantaneously, beginning its work before the target has had any opportunity to register what has happened. In many cases, the prey is paralyzed before it has fully understood that it has been struck. The jellyfish, meanwhile, continues to drift. It has no awareness of what just occurred. It has no brain with which to celebrate a successful hunt, no nervous system complex enough to register satisfaction or relief. It simply continues on its slow and ancient path through the water, and the tentacles continue to trail behind it, each one covered in thousands upon thousands of cnidocytes, each cnidocyte housing its nematocyst, each nematocyst waiting in its coiled and pressurized silence for the next moment of contact. There is something deeply calming about this if you allow yourself to feel it. Not the sting itself, of course, which is by design anything but calming, but the waiting, the sheer scale of waiting that is involved. An entire jellyfish, a creature composed almost entirely of water and translucence, trailing through the ocean for days or weeks or months, and all along its length, in every cell of every tentacle, this unimaginably precise mechanism sits loaded, ready, patient. It does not tire. It does not lose focus. It does not wonder if the moment will ever come. It simply waits in the way that small and perfect things wait, with the whole of their existence gathered into that readiness, and nothing left over for anything else. Now, you may have heard at some point in your life that a jellyfish can sting you even after it is washed up on a beach, even after it has died. And this is true, and it is one of those facts that initially seem strange, almost unfair, until you understand the mechanism behind it, and then it becomes simply elegant. Because the nematicist does not require the jellyfish to be alive in order to fire. It does not require a nervous signal from a living animal. It requires only its trigger, that chemical or mechanical stimulus that causes the capsule to open and the tubule to discharge. This trigger can still be activated in a dead tentacle. It can be activated in a tentacle that has become detached from the animal entirely, floating free in the water or lying still on a wet shore. The mechanism is self-contained in a way that most biological processes are not. It carries its own readiness within itself, independent of the larger life that created it, operating with the same efficiency whether its host is living or dead, present or absent, whole or scattered by wave and wind across a stretch of summer sand. This is worth remembering as a matter of gentle caution if you ever walk the shore in places where jellyfish are known to visit. What looks like an empty strand of translucent tissue, barely visible against the wet sand, may still be capable of making itself known to you. Not with malice, not with any intention whatsoever, simply because the mechanism works, and the mechanism does not know when to stop working, because stopping was never part of the design. And yet, and this is perhaps the most reassuring part of the whole story, the vast majority of jellyfish species pose no danger to humans at all. Of the thousands and thousands of species that drift through the world's oceans, and there are thousands shaped and colored and sized in ways that range from barely visible wisps of protein to bell-shaped bodies wider than a doorway, only a relative handful carry venom potent enough to cause significant harm to a person. Most jellyfish stings, if a person encounters them at all, produce nothing worse than a brief and mild irritation, something that passes quickly, leaving behind only the strange and slightly sheepish memory of having been startled by something invisible. The ocean's most ancient weapon is, in most cases, aimed at prey much smaller than us, calibrated for creatures whose size and vulnerability have nothing to do with our own. This is one of the kinder truths about the natural world, that what seems threatening to us from the outside is usually not designed with us in mind at all. The jellyfish does not hunt us. Its nematocysts were not built for our particular skin. We are, in the long story of the jellyfish and its relationship with the ocean, entirely incidental. We wander into the story occasionally, and we emerge from it surprised and sometimes briefly uncomfortable, and the jellyfish drifts on without having noticed us at all. There is a peculiar kind of peace in this realization, to know that something so powerful, so fast, so mechanically astonishing has no particular relationship with you. To know that you can move through the same water as this ancient and marvelous animal and be, for the most part, entirely irrelevant to its existence. And so the tentacles trail, and the nematocysts wait, each one a universe of compressed precision inside a space too small to see without instruments designed for smallness, instruments that let us peer into the architecture of the very tiny and find there not emptiness but complexity, not simplicity but a kind of genius, so old it predates almost every other form of life we know. Each cell a small world. Each nematocyst a mechanism refined beyond what evolution usually bothers to refine, because this particular trick was so successful, so perfectly suited to the demands of life in moving water, that it was preserved intact across geological time, carried forward through every mass extinction, every shift in ocean chemistry, every transformation of the planet's surface and climate, untouched and unchanged in its fundamental operation, still firing in 700 nanoseconds, still generating its 5 million G, still entirely indifferent to the fact that it is extraordinary. And tucked inside each microscopic cell, coiled with a patience and precision that no human hand could ever replicate, this tiny instrument waits in stillness for a moment that may never come, suspended in a readiness as perfect as tucked inside each microscopic cell, coiled with a patience and precision that no human hand could ever replicate. This tiny instrument waits in stillness for a moment that may never come, suspended in a readiness as perfect as the ocean itself on a windless morning. When the surface has gone to glass and the sky and the sea become one unbroken mirror and everything holds its breath. And it is in that kind of stillness, that quality of waiting without urgency, that we begin to understand something of the jellyfish. Not the creature we might picture drifting lazily through a sunlit aquarium, trailing its ribbons of translucent silk, but the creature before that, the creature beneath that, the creature in its other life, the life that most of us never see and never think to wonder about. Because the jellyfish, that most ethereal of ocean wanderers, does not begin its life as a creature of open water. It begins much closer to the earth. It begins as something almost impossibly small, anchored to a stone, breathing in the patient dark. To understand this, we have to let go of the idea that a living thing has one single form, one fixed and permanent shape. We are accustomed to thinking of creatures as constant. A dog is a dog from birth to death. A tree is always recognizably a tree. But nature has always been far more imaginative than we give it credit for, and the jellyfish is one of nature's most inventive dreamers. It wears two completely different bodies across the arc of its life. It is two creatures, and yet it is one. It lives two kinds of existence, and yet it is continuous. This is not transformation in the way we think of a caterpillar dissolving into a butterfly, though that too is extraordinary. This is something older, something that feels almost mythological, a cycling between worlds that has been repeating, unbroken, for hundreds of millions of years. The first form is the polyp. Imagine something very small and very still. Imagine a pale, delicate cylinder, no larger than a grain of rice, clinging to a rock or a shell or a smooth, flat surface on the seafloor with a kind of gentle tenacity. At its base, it holds fast. At its top, it opens like a tiny flower, a crown of tentacles spread wide, waiting for whatever the current might bring. The polyp does not swim. It does not wander. It is a creature entirely of place, rooted in its small patch of ocean, as quietly as a moss clings to a shaded stone in a forest. And yet there is nothing passive about it. It is feeding, growing, sensing the temperature and chemistry of the water around it, listening in its own way to the slow seasonal pulse of the sea. The polyp has a secret gift, one that speaks to a kind of abundance almost beyond imagining. It can reproduce without a partner. Through a process called budding, it simply grows new versions of itself, small extensions that swell outward from its body like buds on a branch in early spring, and then separate and become their own beings. One polyp becomes two. Two become four. A colony of identical individuals, each one a continuation of the last, spreads quietly across the seafloor like a whispered conversation passed from one voice to the next. There is no drama here, no courtship, no merging of two different lives. There is only the quiet arithmetic of growth, patient and unstoppable, carried out in the dark. But the polyp can also do something even more remarkable than simply multiplying. Under conditions of stress, perhaps when water temperatures shift, or food becomes scarce, or the light changes in some subtle way that only the polyp can perceive, something new begins to stir inside it. The polyp starts to change. It begins to segment itself, like a stack of coins slowly separating, each layer pulling apart from the one below it in a process called strobilation. And from the topmost layer, the first of them begins to break free. What emerges is something so different from the polyp that it seems almost impossible they share the same identity. This new creature is called an ethereal. It is tiny, barely visible to the naked eye, and it pulses. It swims. It rises. The ethereal looks like a snowflake made of living light, 8 delicate arms arranged in perfect radial symmetry, each one notched and feathered at its edge, the whole creature no bigger than a child's thumbnail. It drifts upward through the water column with a motion that is both purposeful and dreaming, a slow rhythmic contraction that carries it toward the surface, toward the light, toward a life that its parent, the anchored polyp left behind on the stone below, will never know. This is the beginning of the medusa, the free-swimming form, the creature we recognize as a jellyfish. The ephemera will grow, gradually filling in the spaces between its arms, becoming rounder, more translucent, more luminous, until at last it is the full adult medusa, trailing its curtain of tentacles through open water, pulsing with that unmistakable slow rhythm that seems to belong not to any individual heartbeat, but to the heartbeat of the sea itself. And when the medusa is fully grown, it will reproduce again, but this time differently. This time it will release eggs and sperm into the water, a sexual reproduction that shuffles the genetic deck and sends something new into the world. The fertilized eggs will develop into tiny free-swimming larvae called planulae, each one a microscopic comma of life, searching for a surface, a stone, a shell, a place to settle and hold fast. And when a planula finds its place and attaches, it will become a polyp, and the cycle will begin again. Polyp to medusa, medusa to polyp, generation after generation, season after season, the wheel turning so slowly that a human lifetime might only see a few of its rotations. There is something profoundly comforting about a cycle this old and this complete. It does not begin and it does not end. It simply continues. It is like watching the seasons change from very far away, from such a great height that spring and autumn and winter and summer blur into a single continuous motion, a breathing in and breathing out that has no first breath and will have no last. The jellyfish carries this ancient rhythm inside it, not as instinct exactly, not as thought, but as something more fundamental than either. As pattern, as the shape that life takes when it has had enough time to find its most elegant form. And the elegance does not stop there. Some jellyfish species carry both possibilities within them simultaneously, capable of both sexual and asexual reproduction at different points in their lives, choosing one or the other depending on the conditions they find themselves in. This is not indecision. This is extraordinary versatility, a deep biological fluency that allows the animal to respond to its environment with a flexibility that feels almost strategic, almost wise. When the conditions are right for meeting and mingling, for genetic exchange and the creation of something novel, the medusa takes that path. When conditions demand efficiency, speed, the multiplication of what already works, the asexual path opens instead. The jellyfish does not choose consciously, of course, but the life itself chooses. And the result is a creature that has survived every mass extinction this planet has ever endured and continued pulsing through the aftermath as though nothing particularly unusual had occurred. Then there is the moon jellyfish, Aurelia aurita, that most familiar of soft-bodied wanderers, the one you might have seen in an aquarium pressing itself gently against the glass, its 4 purple rings visible through its translucent bell like shadows of flowers seen through frosted ice. Aurelia aurita has a gift that feels less like biology and more like something from a dream about healing. When it is injured, when something tears its soft body or stress degrades it beyond the point of easy recovery, the moon jellyfish can do something extraordinary. It can deconstruct itself. It can revert to an earlier form, breaking down its medusa body and reorganizing its cells into new polyps, multiple individuals budding from the remains of one. The creature that was injured becomes several creatures, each one whole and intact, each one carrying the full potential for the life cycle to begin again. Damage becomes multiplication. Loss becomes abundance. This is not metaphor. This is what the cells actually do, guided by processes so finely tuned that scientists are still working to understand the molecular language in which these instructions are written. There is a kind of philosophy in this, if you are willing to receive it quietly, without forcing it into meaning. The moon jellyfish does not resist its injuries. It uses them. It does not attempt to hold its shape against the pressures that would change it. It yields to the change, and in yielding, it multiplies. There is something in this that feels like a lesson, though perhaps the gentlest way to hold it is simply as a fact, a beautiful fact about a beautiful animal, and let it rest there in the mind like a stone on the bottom of a shallow pool, catching light from above without needing to be anything other than what it is. And then there's the waiting, because the polyp does not only grow and bud and transform, sometimes it does something even more quiet than that. Sometimes it stops, under conditions that are not yet right, when the water is too warm or too cold, when the chemistry is off, when the signals that trigger strobilation have not yet arrived, the polyp can enter a state of dormancy. It can pull itself in, reduce its metabolic activity to almost nothing, and simply wait. For months, for years in some cases, the jellyfish polyp can persist on the seafloor through seasons it does not bloom into, through winters it sleeps through years that pass above it like clouds passing over a mountain that does not notice them. It is waiting for the right conditions, not with impatience, not with anxiety, but with the absolute and total equanimity of something that has no concept of time as loss. The right moment will come, or it will not. The polyp holds its place either way. This dormancy is not death. It is a different quality of being alive, one that we warm-blooded, fast-metabolizing, always-moving creatures find difficult to fully imagine. It is aliveness turned down to the quietest possible volume, a whisper of existence that nonetheless contains within it everything necessary for the full flowering of life when conditions permit. The polyp on its stone is not waiting for its life to begin. Its life is already happening, in that stillness, in that patient endurance, in that slow, watchful dark. And when the conditions finally shift, when the water cools to the right temperature and the chemical signals arrive, and something like spring returns to that small patch of seafloor, the polyp will respond. Not with urgency, not with anything that resembles excitement as we understand it, but with the steady, unhurried opening of a process that has always been inevitable, always been written into it, waiting only for the world to catch up. The transformation will begin again. The segments will form. The ephrae will separate and rise. From a single resting polyp clinging to a quiet stone on the ocean floor, a whole new generation might slowly unfurl, each tiny ephira spinning upward toward the light like a thought rising gently from the edge from a single resting polyp clinging to a quiet stone on the ocean floor. A whole new generation might slowly unfurl, each tiny ephira spinning upward toward the light like a thought rising gently from the edge of sleep. And it is here, in this soft and ancient darkness, in this place where the ocean holds its breath and the currents move like slow, dreaming exhalations, that we find perhaps the most quietly astonishing creature the sea has ever kept secret. It does not roar. It does not glow with dramatic bioluminescence. It does not span the length of a room or drift like a ghostly curtain through the deep. It is, by almost any measure, unremarkable in size, and yet within its nearly invisible body, this small and gentle animal carries something that has made scientists pause, put down their instruments, and simply stare into the water with wide, wondering eyes. Its name is Turritopsis dohrnii, and it is, in the most precise biological sense of the word, immortal. Let that word settle over you for a moment, the way a blanket settles when someone tucks it gently around your shoulders. Immortal, not a metaphor, not a myth, not the wishful thinking of an ancient civilization pressing stories into clay tablets. A real, living, breathing, pulsing creature, translucent as sea glass, smaller than your smallest fingernail, drifting through the warm coastal waters of the Mediterranean and beyond, quietly doing something that almost nothing else in the animal kingdom has ever learned to do. It is turning back time, not in a dramatic flash of light or a violent reversal, but slowly, softly, the way a tide pulls back from the shore in the deep of night when no one is watching. Turritopsis dohrnii is a jellyfish, though the word jellyfish perhaps conjures images too large and too dramatic for this delicate animal. When fully grown, it measures only about 4.5 millimeters in diameter. 4.5 millimeters, smaller than a pencil eraser, smaller than the nail of your smallest finger, smaller than a raindrop on a window pane, and yet fully formed, fully alive, pulsing with quiet intention through the water column, its transparent bell contracting and relaxing in a rhythm so gentle it seems almost like breathing. Like all jellyfish, Turritopsis dohrnii begins its life as a polyp, a tiny sessile creature anchored to a rock or a shell or some other firm surface on the ocean floor. This polyp is the juvenile stage, small and unassuming, just a little column of cells attached to the world below, waiting. In time, it buds and transforms, releasing the free-swimming Medusa stage, the form we would recognize as a jellyfish proper, a pulsing bell with trailing tentacles, drifting upward into the water where light filters down from somewhere far above. This transformation from polyp to Medusa is, in most jellyfish, a one-way door. Youth becomes adulthood. The clock ticks forward. The animal lives and then it dies, as all things do. But Turritopsis dohrnii, this tiny wanderer, this small philosopher of the sea, discovered something extraordinary. It found the door swings both ways. When the immortal jellyfish is placed under stress, when it is threatened or injured, when food becomes scarce, when the water grows too cold or too warm, or simply when the long arc of aging begins to curve toward its natural end, something happens inside its cells that has no real parallel anywhere in the animal kingdom. The adult Medusa, fully grown, fully mature, does not die. Instead, it sinks. It settles. Its bell contracts slowly inward. The tentacles are reabsorbed, and the animal collapses into a small, still mass, like a thought deciding to become a dream. And then, with a patience that seems almost meditative, it transforms. It reverts. It becomes once more a juvenile polyp, anchoring itself to whatever surface is nearby and beginning the whole cycle of life again from the very beginning. This is not merely a metaphor for renewal. This is real. This is happening right now in warm, shallow waters, in research tanks and laboratories, in the unhurried depths of bays and harbors, in all the quiet places where this small creature drifts. The adult becomes the child. The ending becomes the beginning. The arrow of time, which we assume always flies only forward, curves gently back on itself and completes a circle so smooth and unbroken that it barely seems real. The process by which this happens has a name, and the name itself is worth pausing on. Transdifferentiation. It is a word that sounds almost magical, like something from a language invented specifically to describe impossible things. Transdifferentiation is what occurs when a cell that is already committed to being one type of cell, a skin cell, a muscle cell, a nerve cell, a cell that has chosen its identity and settled into its purpose, decides to change. Not merely to divide or to multiply, but to become something else entirely. To abandon what it was and choose a new role, a new function, a new future. In most animals, this simply does not happen. Cells, once differentiated, once committed to their particular role in the great cooperative project of a body, stay committed. This is part of what makes organisms stable, what keeps your skin from suddenly deciding to become liver tissue, what maintains the careful architecture of a living thing. Cells choose their identities early, and they keep them. There are mechanisms, deep and ancient and reliable, that enforce this commitment. Differentiation, in most of the animal kingdom, is final. But Turritopsis dohrnii has found a way around this. Its cells, when the signal comes, when stress or age or some internal tide reaches a certain threshold, do something extraordinary. They revert, they dedifferentiate first, stepping back from their specialized roles into a more generalized state, and then they redifferentiate into something entirely different. A cell that was part of the adult medusa's bell becomes a cell in the juvenile polyp's column. A cell with one function becomes a cell with another. The body remakes itself from within, not through the addition of new material, but through the quiet transformation of what was already there. Scientists who study this process use language that is careful and precise because they are scientists, and precision is their form of love. But even beneath the careful language, you can sometimes sense the quiet astonishment. Transdifferentiation is rare. True, complete, whole organism transdifferentiation leading to full biological reversal is, as far as we know, unique to Turritopsis dohrnii in the entire animal kingdom. It is the only animal we know of that is theoretically capable of repeating this cycle not once, not twice, but indefinitely. As long as it is not eaten, as long as it is not struck by some external misfortune, this jellyfish could, in principle, cycle through the stages of its life forever. Medusa to polyp, to medusa to polyp, round and round, turning back whenever the turning is needed, never truly reaching an end. Biologically immortal, the phrase sounds like something from a story, but it is, as best as scientists can determine, simply true. There is something deeply quieting about this, something that invites a kind of philosophical gentleness. We spend so much of our time thinking about time as a line, as a road that stretches forward and does not turn back. We imagine our lives as arrows, always moving in one direction, always spending what cannot be regained. And here in 4.5 millimeters of transparent ocean animal is a gentle challenge to that assumption. Not a dramatic challenge, not an argument or a confrontation, just a quiet, drifting presence that says, in its wordless way, that perhaps the rules we think of as absolute are a little more flexible than we imagined. That perhaps the story of a life does not have to be told in only one direction. Researchers around the world have become fascinated by Turritopsis dohrnii, and not only because it is philosophically interesting, though it certainly is that. They are interested in it because the mechanisms it uses might, in some distant and careful way, offer insights into some of the most pressing questions in biology. How do cells age? What controls the process of differentiation, and can it be guided or redirected? What switches deep in the molecular machinery of a cell determine whether it holds on to its identity or lets it go? These questions matter not just for jellyfish, but for all of us, for understanding cancer, which is in part a story of cells losing their proper identities and functions, for understanding regeneration, for understanding why some tissues in our own bodies can heal and others cannot, and for the broader ancient human dream of understanding why we age and whether the mechanisms of aging are as fixed and inevitable as we have always assumed. The immortal jellyfish is, in this sense, not just a wonder to be admired, but a collaborator in a long conversation between science and the unknown. It pulses in its laboratory tanks, indifferent to the attention, unbothered by the instruments and the careful eyes watching it through glass. It does not know it is extraordinary. It simply does what it has always done, what its lineage has been doing for millions of years in the warm margins of the sea. It lives, it ages, it reverts, it begins again. The process is as natural to it as breathing is to you, as natural as the slow settling of your body into sleep, the way tension leaves your shoulders 1 degree at a time, the way your thoughts soften at the edges and lose their sharp insistence. There are scientists who have spent years studying this animal, years learning its habits and its triggers, years peering into the molecular mechanisms of its impossible reversal, and who still describe it with something approaching reverence. Not the reverence of awe that collapses into speechlessness, but the reverence of deep familiarity that only deepens the more you understand. Because the more you understand about Turritopsis dohrnii, the more astonishing it becomes. Every answer opens another question. Every mechanism once traced reveals another layer of elegant complexity beneath it. It is the way the best scientific discoveries tend to go, not toward simplicity, but toward a richer, more intricate wonder, a wonder that feels less like confusion and more like standing at the edge of something vast and realizing that vastness is not threatening, but beautiful. Imagine the animal itself, drifting in the water column at this very moment, somewhere in the Mediterranean perhaps, or in a harbor in Japan, or along the coast of wherever warm and sheltered waters gather. 4.5 millimeters of life. The bell pulses, slow and rhythmic, a tiny heartbeat in the dark water. The tentacles trail behind, delicate and transparent, barely visible against the shifting light. Inside, cells are going about their quiet business, performing the intricate chemistry of existence with a precision and a grace that no human engineer has yet managed to replicate. And somewhere in those cells, written in a molecular language older than almost anything we can imagine, is the instruction for the great reversal, the knowledge of how to step backward through time, how to become young again when the need arises, how to fold the future back into the past and begin the whole journey once more. It is not a loud miracle. It never announces itself. The jellyfish does not pause in its drifting to acknowledge what it is doing, does not wait for applause or recognition. It simply reverses, quietly, thoroughly, completely, the way a river might reverse its course if the land tilted gently the other way. And then it is a polyp again, small and still and anchored, waiting with the patience of something that has all the time in the world, because it does. It really does. When we think about the ocean at night, when we imagine its depth and its darkness and the unfathomable variety of lives being lived out in its quiet interior, it is comforting to remember that among all those lives is this one, this tiny, gentle, endlessly cycling life. A creature that has solved in its own humble way the problem that preoccupies so much of human thought and human fear. It does not conquer death through force or through drama. It simply steps around it, softly, without fuss, the way you might step around a puddle on a quiet evening walk, barely breaking stride, continuing on into the gentle dark. The scientists who study Turritopsis dohrnii are careful to note that biological immortality is not the same as invincibility. The jellyfish can still be eaten. It can still be killed by pollution or by physical damage. Its immortality is a biological potential, a capacity held within its cells, not a guarantee of endless life in a world full of hungry mouths and changing conditions. But the potential itself is extraordinary. The fact that this reversal is possible at all, that a living animal can restructure itself so completely that cells can abandon their commitments and begin again. This is the thing that keeps researchers returning to their tanks and their microscopes and their patient, wondering observations. And so this tiny creature, no larger than a fingernail, carries within its translucent body a secret that has fascinated scientists and dreamers alike. The possibility that time itself might be, and so this tiny creature no larger than a fingernail carries within its translucent body a secret that has fascinated scientists and dreamers alike. The possibility that time itself might be something more flexible than we have always imagined. Something that folds back on itself like a tide returning to the shore it never truly left. But tonight, we are going to let that small and astonishing creature drift gently away on its invisible current. And we are going to turn our gaze outward, much further outward, to where the ocean deepens and widens and becomes something so vast that the mind can only soften in its presence, can only release its grip and let itself be carried. There are moments in the ocean's long history when something extraordinary happens. Not a storm, not a shipwreck, not the dramatic breach of a whale against the horizon. Something quieter than all of those things and in its own way more strange. The water changes, the temperature shifts just slightly, just enough. The plankton rises in great invisible clouds through the water column, a feast laid out by chemistry and light. The currents slow. The surface of the sea becomes almost perfectly still, like a held breath, like a room where everyone has paused at once and nobody quite knows why. And then from the blue-green depths they come. They are called a bloom, sometimes a swarm, and sometimes, in a word that feels exactly right for their sheer improbable numbers, a smack of jellyfish. Say it quietly to yourself and notice how it sounds like both a collision and a kiss, like something arriving all at once with more presence than you expected. A single bloom can contain millions of individuals, millions of these soft and pulsing beings, gathering in a convergence so dense it seems impossible. Seems like something that should not be able to happen in the open water of the world's largest wilderness. And yet it does. Again and again, in seas all over the planet, in waters both warm and cold, in bays and open oceans and shipping lanes and the passages between islands, the jellyfish come together in their uncountable numbers, and the sea becomes something else entirely. If you were to stand at the bow of a ship moving through one of these blooms, you would look down into the water and see them stretching in every direction as far as visibility allowed, which in clear tropical water might be 30 or 40 feet. And in every one of those 30 or 40 feet, there would be more of them, layer upon layer, a three-dimensional cathedral of soft bodies and trailing arms. Moon jellies with their four pale horseshoe markings, their edges fringed like lace. Lion's mane jellies with their rust-red curtains of stinging tentacles billowing behind them like smoke. Cannonball jellies, solid and round and almost cheerful looking, moving through the water with a patient, methodical pulse. Each one alone would be a small wonder. Together, in their millions, they become something that beggars description. Something that lives in the category of natural events that the human mind processes slowly over days and weeks rather than all at once. The conditions that allow a bloom to form are a kind of temporary alignment, an ocean weather event made not of wind and clouds but of warmth and stillness and abundance. When the water temperature rises to just the right degree, when the surface calms and the plankton blooms first, feeding the tiny polyps that will release their medusae into the water column, when the currents arrange themselves in ways that concentrate rather than disperse, then the bloom can happen. It is not random, though it can seem that way from the surface. There is an intricate choreography behind it, written in the language of salinity and temperature gradients, and the invisible patchwork of ocean productivity. Scientists study these conditions with instruments and satellites and the careful analysis of decades of data. But even they, standing at the edge of a bloom with all their knowledge assembled around them, sometimes say that it feels like something more than the sum of its parts, that it feels, in the oldest sense of the word, like a phenomenon. And blooms have been growing. In many parts of the world, the smacks are arriving more frequently, staying longer, reaching further than they once did. Warming oceans, changing with a slowness that is still faster than anything in the geological record of recent centuries, seem to be expanding the windows of favorable conditions, stretching the seasons in which jellyfish thrive. Overfishing has removed many of the creatures that once competed with jellyfish for plankton, or that once kept their numbers in a kind of natural equilibrium. The fish are fewer, the jellyfish are more, and so the balance shifts, quietly, ocean by ocean, bay by bay, the way so many of the world's deep balances are shifting, not with a crash, but with a long and gradual lean, like a ship taking on water slowly enough that no single moment feels like the moment of change. The consequences of these growing blooms are sometimes dramatic in ways that seem almost farcical, almost too strange for a serious scientific discussion. Power plants have had to shut down because jellyfish blooms clogged their cooling water intakes, millions of soft bodies pressing against the filters in a slow and utterly indifferent siege. Naval vessels have been disabled, their systems overwhelmed by the sheer physical mass of a bloom moving through waters where military maneuvers were being conducted. Fishing nets dragged through bloom-thick water come up so full of jellyfish that the intended catch is lost beneath them, crushed or contaminated, and the fishermen stand at the stern of their boats looking at their haul of soft, stinging bodies and feel the particular frustration of a world that has rewritten the rules without asking permission. There is something almost mythological about these events, about the image of great human machines brought low not by fire or violence, but by the quiet, pulsing insistence of millions of ancient and boneless creatures doing nothing more intentional than drifting together in the same warm water. But to think of jellyfish only as a problem, only as an inconvenience or an ecological alarm signal, is to see only one face of something that has many faces, most of them turned away from us, gazing into depths we cannot follow. Because these blooms, for all their disruption to human systems, are feasts. They are banquets laid out on the open water for creatures that have been eating jellyfish for millions of years, long before any human built a power plant or dragged a net. The leatherback sea turtle, ancient and enormous, its shell, like a mosaic of bone and cartilage, crosses entire ocean basins in the pursuit of jellyfish blooms. It has been doing this since before the last ice age, following the same chemical traces and temperature gradients that draw the blooms together, arriving at them with a precision that seems almost impossible given the scale of the journey. A single leatherback may eat hundreds of pounds of jellyfish in a single day during a good bloom, fueling a body that can weigh close to 1,000 pounds on a diet that is almost entirely soft water and trailing tentacles. The ocean sunfish, that extraordinary and improbable creature that looks like a swimming head, a fish that decided somewhere in its evolutionary history that a tail was unnecessary and simply did away with it, also lives largely on jellyfish. It drifts through blooms with an unhurried deliberateness, its enormous flat body tilting sideways near the surface, sometimes to warm in the sun between feeding dives, so massive and so strange that sailors who encountered it for the first time often thought they were seeing something wounded, something wrong with the world. But the sunfish is not wrong. It is perfectly adapted to a life of jellyfish, to the patient following of blooms across the open ocean, to a diet that seems impossibly insubstantial for a fish that can weigh over a ton. Certain seabirds, too, have learned to read the surface signs of a bloom below, to dive and pluck jellyfish from the upper water column in a behavior that is still being documented and understood, still being added to the long catalog of ways that the ocean's creatures have woven themselves together into dependencies and partnerships that we are only beginning to fully see. Think about what a bloom means, then, in the broadest sense. It is not just a gathering. It is not just a disruption or a spectacle or an alarm. It is an event that reorganizes the local ocean around itself, that draws predators from great distances, that concentrates energy and matter in a place where other things can happen, other meetings can occur, other connections can be made. The turtle arrives. The sunfish arrives. The seabirds circle. The bloom, in its millions, becomes a temporary node in the vast and invisible web of the ocean, a place where threads pull tight for a time before relaxing again. The web settling back into its ordinary looseness, waiting for the next alignment of warmth and calm and plankton abundance to draw it taut again. There is something in the cyclical nature of blooms that echoes other natural cycles we find soothing: the return of the swallows, the rising of the spring wildflowers, the annual run of salmon back to the rivers where they were born. There is a pattern beneath the apparent randomness, a heartbeat beneath the apparent chaos. And when we recognize it, we feel something that is not quite reassurance, but is close to it. The ocean knows what it is doing, even when what it is doing is unfamiliar or disruptive to us. The jellyfish have been blooming for a very long time. They were blooming when the first fish were learning to swim. They were blooming when the first turtles returned to the sea. They were blooming in warm Cretaceous oceans beneath skies patrolled by pterosaurs, and they will be blooming in some form long after any tally of current events has been forgotten by the planet and replaced with new ones. And there is something calming in that, if you let yourself feel it. Something that the shore has always offered to people who stand at it long enough, who stay past the point of counting waves, who let the scale of the water settle into them gradually, like warmth or like the slow arrival of sleep. The ocean is not indifferent to us the way we sometimes fear it is. It is simply occupied with something much larger than us, a work of such scope and such duration that our place in it is very small, very new, very tender. And small and new and tender things can rest. They are allowed to rest. The bloom will come without our help, and the turtles will find it without our guidance, and the sunfish will drift and tilt and feed in its ancient unhurried way, and none of this requires our vigilance or our worry. It only requires our wonder, which is something we can give freely from wherever we are, even lying here in the dark, with our eyes half closed and the night settling around us like water, like the surface of a warm and quiet sea. Let the breath come slower now. Let the body find its heaviness, the particular sweet weight of a person finally still. Somewhere out there, in the real dark water of the real world, the jellyfish are moving. Millions of them, billions. In their soft and pulsing silence, they are going about the ancient business of being alive in the only way they know, which is completely and without reservation, with every cell of their boneless and beautiful bodies. And if you wanted to, just for a moment, before the thoughts grow too light to hold, you might imagine drifting just beneath the surface of a warm summer sea, surrounded on all sides by millions of softly pulsing forms, each one moving in its own quiet time and feeling not afraid but somehow carried, held within something imagined drifting just beneath the surface of a warm summer sea, surrounded on all sides by millions of softly pulsing forms, each one moving in its own quiet time, and feeling not afraid but somehow carried, held within something much older and much gentler than fear. That feeling, that strange and unexpected sense of belonging to the water, of being welcomed rather than threatened, is perhaps the truest thing jellyfish have ever given us. Not the sting, not the mystery, but the reminder that we are guests in a world that was here long before us, and that the creatures who share it with us have been shaping our lives, our stories, our science, and our tables in ways we are only just beginning to fully understand. Long before anyone had a microscope, long before the word biology existed, people were watching jellyfish. They were noticing them, wondering about them, writing about them, and occasionally eating them. The relationship between humans and jellyfish is not new. It is ancient, and like all ancient things, it carries layers. In parts of Asia, jellyfish have been eaten as a delicacy for more than 1,700 years. 17 centuries. Think of what the world looked like 17 centuries ago, how different the cities, the languages, the stars people navigated by, and yet there were people then sitting down to carefully prepared jellyfish, the same creature we study today, the same pulsing bell, the same trailing arms, transformed by the patient work of drying and salting into something tender and translucent on the plate. The preparation has always been thoughtful. Jellyfish are first dried, then salted sometimes for weeks, a slow alchemical process that changes their texture and draws out excess water, leaving behind something that is faintly crunchy and mild and capable of absorbing the flavors around it. They appear in Chinese cuisine most often, sliced thin and dressed with sesame oil and vinegar and a whisper of chili, or served cold as a refreshing appetizer at the beginning of a celebratory meal. In Japan, they become a delicacy called kuraage, prepared with care and reverence. In Korea, in Southeast Asia, In communities scattered all across the Pacific coast, jellyfish have been a part of the culinary fabric for so long that they are simply a fact of the table, unremarkable in their familiarity, the way a food can only become when it has been known for generations. There is something quietly moving about this, that a creature so alien, so unlike us in every structural way, something without a stomach that digests, without teeth, without any recognizable feature of appetite or preference, has nonetheless found its way into our recipes, our celebrations, our grandmother's kitchens. Food is one of the most intimate forms of relationship. When we eat something, we take it inside us. We make it part of our bodies. We carry it forward. To have eaten jellyfish for 1,700 years is to have carried the ocean into our cells for 1,700 years in the most literal and lovely way. But the relationship between humans and jellyfish does not begin only with eating. It begins, as so many human relationships with the natural world do, with encounter and wonder and a little bit of fear. Ancient Roman physicians wrote about jellyfish stings. They noted the burning sensation, the redness, the inflammation, and they prescribed remedies that ranged from the practical to the poetic, olive oil and vinegar, and the application of cool clay. That they wrote about jellyfish at all tells us something important. These were creatures that mattered enough to document. They appeared in the margins of maps. They drifted through mythology. Across many cultures, the jellyfish became a symbol of the deep and unknowable sea, of things that glowed and drifted and could not quite be grasped. In Japanese folklore, there are stories of the Karaj, the boneless ones, creatures that once had bones but lost them through some ancient misfortune or divine judgment, leaving them soft and homeless in the water ever since. In these stories, there is a kind of wistfulness, a gentle melancholy for something that gave something up and floated on regardless. They appear in art across centuries and continents. In delicate Japanese woodblock prints, their bells rendered with extraordinary precision, every trailing filament accounted for, every subtle gradation of color honored. In the illuminated manuscripts of medieval Europe, where sea creatures of all kinds were catalogued with a mixture of genuine observation and magnificent imagination. In the paintings of the Art Nouveau movement, where artists like Ernst Haeckel elevated jellyfish to icons of natural beauty, his detailed illustrations so stunning and so symmetrical that they became design motifs, appearing on wallpapers and textiles and architectural ornamentation, the jellyfish becoming in the early 20th century a kind of aesthetic muse, a symbol of elegant biological complexity. Haeckel's drawings of radiolarians and medusae were not merely scientific documents, they were celebrations, acts of visual devotion to the strangeness and perfection of life in the sea. People hung them on their walls. They saw in those forms something that resonated, something that felt true and beautiful and worth looking at for a long time. And then, much more recently, something happened that changed biology forever, and it happened because of a small and unassuming jellyfish that glows in the dark. Aquaria victoria is a crystal jellyfish, pale and barely visible in daylight, drifting along the Pacific coast of North America in great quiet numbers. In the dark, under ultraviolet light, it glows green. This was observed, noted, and eventually painstakingly investigated by a scientist named Osamu Shimomura, who spent actual years of careful and often frustrating laboratory work, isolating the protein responsible for that green glow. He called it green fluorescent protein, and no one at the time could have predicted what would follow. Green fluorescent protein, now almost universally known simply as GFP, became one of the most important tools in the entire history of modern biology. The reason is almost impossibly elegant, because GFP is a protein, which means it is encoded by a gene, which means that gene can be attached to other genes, the genes of other proteins inside living cells. When scientists do this, when they take the GFP gene and stitch it gently alongside the gene for another protein they want to study, what happens is that the target protein begins to glow green in the dark, inside a living cell, inside a living organism, without any external dye, without any chemical intervention that might damage or alter what is being observed. The cell simply shows you, in cool, luminous green, exactly where your protein of interest is, what it is doing, where it travels, how it behaves. This sounds simple, but the implications are extraordinary. Before GFP, watching proteins inside living cells in real time was extraordinarily difficult. You could fix cells in place, stain them with dyes that killed them in the process, and look at frozen snapshots of life. But you could not watch life happening. GFP changed that. Suddenly, scientists could tag a single type of neuron in a mouse brain and watch it light up during a thought. They could label cancer cells and watch how they moved and spread through a living body. They could mark proteins involved in diseases like Alzheimer's and follow them in real time as the disease progressed, learning things about the mechanics of illness that had been invisible before. They could watch the moment a fertilized egg divided for the first time, tracking the precise choreography of cell division in living color, in a living creature, without disturbing the process at all. The Nobel Prize in Chemistry was awarded in 2008 to Shimomura and the two scientists who developed his work further, Roger Tsien and Martin Chalfie. Tsien in particular was responsible for engineering variants of GFP that glowed not only green but blue, yellow, cyan, red, a whole luminous palette derived from tweaking the original jellyfish protein, each color allowing scientists to tag different things at once and watch them all simultaneously. The result was sometimes described as painting cells from the inside. The images produced using these fluorescent proteins are not only scientifically invaluable, they are breathtakingly beautiful. Fields of glowing color in the darkness of a cell, neurons lighting up like constellations, proteins blooming and traveling and interacting in a silent living light show that no artist could have imagined before biology provided it. All of this profound and world-altering science, it came from a small glowing jellyfish drifting in the cold water off the coast of Washington and British Columbia. A creature that was not trying to be useful. A creature that was simply being itself, glowing for its own quiet reasons, in the dark water where nobody was watching. Until someone was. And the gifts of jellyfish to science do not stop there. They continue in different registers at different scales, offering themselves to our curiosity in ways that feel, if you let yourself feel it, almost generous. Jellyfish collagen is one of the newer frontiers. Collagen, the structural protein that holds animal tissues together, is extracted most commonly from pigs or cows, which creates complications, religious and cultural restrictions for some patients, the risk of disease transmission from land mammals, and growing concerns about the ethics and sustainability of large-scale animal farming. Jellyfish offer an alternative that is proving genuinely promising. Their collagen is structurally similar to mammalian collagen in the ways that matter most, but it comes from a creature with no central nervous system, no blood, no parasites that cross to humans, and no religious prohibition attached to it. Researchers are studying jellyfish collagen for use in wound dressings, where its biocompatibility and ability to support tissue repair make it an excellent candidate for healing difficult wounds and burns. They are studying it for tissue engineering, the young and extraordinary field in which scientists attempt to grow replacement tissues and even organs in the laboratory, work where scaffolding made of biocompatible collagen is essential. They are studying it for cosmetics, where collagen is already a beloved ingredient for its role in skin elasticity and hydration, and where a sustainable marine source could replace the less elegant alternatives currently in use. There is a poetic symmetry to this. The creature that has been associated for centuries with stinging and burning and the discomfort of the sea may ultimately help heal wounds. The creature that seems too fragile, too ephemeral, too soft and boneless to be of structural use may provide the scaffolding for growing new human tissue. The world offers these reversals with a quiet frequency if you are paying attention. And then there are the robots. This is perhaps the most unexpected chapter in the story of jellyfish and human science, and it carries its own particular charm. Engineers studying underwater propulsion have long struggled with a fundamental problem. Most human-made underwater vehicles are inefficient. They work against the water rather than with it. They move through it with force rather than with grace. Jellyfish, who have been moving through the ocean for 500 million years, have solved this problem in ways that are only now being understood and translated. Researchers studying jellyfish movement patterns and nerve nets, the simple but elegant distributed nervous systems that coordinate the bell's pulsing rhythm, are developing robotic jellyfish that mimic that motion. The jellyfish propulsion mechanism, the way the bell contracts to create a jet of water and then relaxes to draw water back in, creating forward movement with minimal energy expenditure, is extraordinarily efficient. It is one of the most energy-efficient forms of locomotion known in the animal kingdom. A robotic vehicle that moves the way a jellyfish moves could, in theory, travel vast distances through the ocean on very little power, navigating silently, disturbing little, monitoring ocean temperatures and currents and chemistry in ways that larger, noisier, more disruptive vehicles cannot. These robotic jellyfish might one day track the effects of climate change in the deep ocean, monitor ecosystems, detect pollution, all by borrowing the ancient wisdom encoded in a nerve net that has no brain behind it, only millions of years of elegant refinement. There is something that feels important about this, about the direction of the learning. We are not teaching jellyfish how to move. We are learning from them. We are sitting with blueprints we did not write, studying solutions we did not devise, and trying to understand the engineering of a creature that never had an engineer. Evolution is the author of that design, patient and unsentimental, and we are the students arriving very late to a lesson that has been in progress for 500 million years. All of these threads, the ancient recipes, the Roman physicians, the woodblock prints and Art Nouveau wallpapers, the Nobel Prize won because of a glowing protein, the wound dressings being tested in laboratories, the underwater robots practicing their soft pulsing motion in tanks, they are not separate stories. They are one story. They are the story of a relationship long and complicated and still unfolding between a strange soft animal and the strange complicated creatures who noticed it, feared it, ate it, drew it, wondered about it, and eventually found inside its body gifts that they could not have imagined looking for. We did not go looking for GFP. We did not plan to find a wound dressing in jellyfish collagen. We did not set out to build better robots by studying the way a mindless bell contracts in the dark water. These things arrived the way all the best things arrive, Sideways, through curiosity, through someone paying attention to something that did not yet seem useful, through the willingness to sit with a creature and watch it be itself until it revealed something extraordinary. Shimomura spent years collecting jellyfish. Years, by hand in buckets, in the cold Pacific water, working quietly with something that most people would have considered not worth the trouble, and the light he found inside it has illuminated more biology than perhaps any other single discovery of the last century. It is a quiet kind of wonder, the way a creature with no brain and no bones and no ambition of any kind has nonetheless woven itself so deeply into the fabric of human knowledge, leaving its luminous mark on laboratories and dinner tables and ancient stories, a soft, persistent presence, reminding us that the most profound gifts sometimes arrive from the softest, most unexpected places, from creatures who never once tried to teach us anything, and yet somehow did. And perhaps that is the most restful thought of all to carry with you now, as the room grows quieter and the edges of the day begin to soften and blur. Perhaps the jellyfish, in all its boneless, brainless, beautiful simplicity, has one final thing to offer us, not a lesson exactly, because lessons require effort and attention and a kind of upright wakefulness that belongs to the daytime world. What the jellyfish offers is something gentler than a lesson. It is more like a permission, a quiet, pulsing, luminous permission to let go. Think of it now. Think of the jellyfish drifting somewhere in the deep blue middle of an ocean you will never see, suspended in water that is older than any human story. It has no destination. This is not a failure of navigation. It is not a flaw in its design. The jellyfish has no fixed destination because it has surrendered wholly and without reservation to the current. It does not fight the water. It does not try to swim against the pull of the tide or argue with the direction of the deep ocean conveyor that moves beneath the surface like a slow and ancient breath. It yields, and in yielding, it finds its way, not to a particular place, not to a goal or a finish line or a reward waiting at the end of some long and effortful journey, but simply to the next moment of sensation, the next shimmer of light filtering down from above, the next soft pressure of water moving around its bell like a gentle hand. There is a word in the language of physics for this kind of movement, this kind of passive, graceful surrender to the forces already in motion around you. But the jellyfish does not know that word. The jellyfish knows only the sensation of moving, the feeling of the current against its trailing arms, the slow rhythmic pulse of its own body as it opens and closes like a breath, like a heartbeat, like the tide itself. It knows this moment, only this moment. Because the jellyfish carries no concept of the past. There is no memory of the current it rode yesterday, no mental map of where it has been or how far it has traveled. And there is no anticipation of what comes next, no anxiety about tomorrow's current or next week's temperature, or whether the water ahead will be warm enough or food rich enough or safe enough. The jellyfish exists entirely in the immediate sensation of water and light. That is all. That is everything. And as you lie here now, in the warmth of wherever you are, with your own breath rising and falling in its slow and natural rhythm, perhaps you can feel something of that. The permission to not know where you are going. The permission to have no fixed destination tonight, no agenda, no place you are trying to reach inside your own mind. The day is behind you now, and the morning has not yet arrived, and in this narrow, quiet corridor of darkness you are, like the jellyfish, suspended between depths, held gently by something larger than yourself, drifting without effort, without resistance, without need. The jellyfish is suspended too, in the most literal and physical sense. Running through the center of its body is a layer called the mesoglia, a word that sounds like something from a dream, soft at the edges, a little blurred, the kind of word that does not quite want to be pinned down. The mesoglia is the jellyfish's jelly, that translucent, trembling substance that makes up most of its body, that gives it its shape and its particular kind of beauty. But the mesoglia is more than beauty. It is a buoyancy aid, a natural flotation device built into the very substance of the creature's being. The density of the mesoglia is so close to the density of the surrounding seawater that the jellyfish is held in almost perfect suspension, neither sinking to the bottom nor floating uncontrolled to the surface, but resting effortlessly in the middle, between the deep dark below and the bright world above. Imagine what it would feel like to be held like that. Not held by something gripping or restraining, not held the way we sometimes feel held by worry or obligation, but held the way water holds a floating thing, gently from all sides at once, with perfect and equal pressure, with no effort required from you at all. The water does not ask the jellyfish to work. The mesoglia does not demand anything. The whole beautiful arrangement is simply a matter of being, of occupying space in the world with exactly the right quality of softness, and finding that the world receives you. Your body, too, is mostly water. More than half of what you are in this very moment is the same substance that holds the jellyfish. And right now, as you breathe, as the weight of your body settles more fully into the surface beneath you with each slow exhale, you are also being held. Gravity is doing its quiet work. Your muscles are slowly releasing. There is nowhere to fall to. You are already arrived. The jellyfish processes the world through something called a nerve net, a distributed web of sensations spread through its body without center, without hierarchy, without a single commanding organ to interpret or judge or decide. When light touches the edge of its bell, the nerve net simply responds. When pressure changes in the water, the nerve net registers it, not as information to be stored or analyzed or worried over, but as pure present moment sensation, immediate and complete and instantly released. There is no part of the jellyfish that holds on to experience. There is no mechanism for rumination, no architecture for replaying the day's events in the deep of the night, no structure capable of rehearsing tomorrow's uncertainties or last year's regrets. The nerve net processes what is happening right now and then it moves on, because the next moment has already arrived and it asks for nothing but presence. This is, perhaps, what the ancient meditators were reaching for, sitting still in cool rooms or beneath open skies, trying to loosen the grip of the thinking mind, trying to find the place beneath thought, where sensation is simply sensation and the present moment is simply the present moment. They were, in their own effortful way, practicing something the jellyfish has never needed to practice, something the jellyfish simply is: a creature of pure present moment awareness, a being that does not drift away from now because now is all there is, because the nerve net has no capacity to wander, no ability to imagine or remember or project, only to feel and to respond and to drift on. You are allowed to drift now too. You have spent the whole long day in your thinking mind, in the planning and the remembering and the anticipating and the managing and the making sense of things. You have worked hard at the business of being a person with a past and a future, and a list of concerns that follows you from room to room like a faithful shadow. But the night asks something different of you. The night, like the ocean current, asks you to yield. to release the grip you have been holding, the one you might not even have noticed you were holding on the direction and shape of your own thoughts. You do not need to steer yourself anywhere right now. The current will carry you. There is a well-documented and quietly beautiful phenomenon that happens when human beings watch jellyfish. Not just observe them in passing, but truly watch them in the blue-lit tanks of aquariums where they drift in slow procession, their bells opening and closing with that mesmerizing regularity, their tentacles trailing in gentle arcs through the water. When people watch jellyfish, their heart rates slow. The rhythm of their breathing becomes deeper, more even. Anxiety loosens its familiar hold. Something in the human nervous system, ancient and wordless, recognizes the rhythm of the jellyfish and follows it down into a quieter register, the way a tuning fork will begin to hum when the right frequency is sounded nearby. No one is entirely certain why this happens, though there are theories, gentle and plausible theories about the rhythm itself, that slow and regular opening and closing that mimics the pace of deep, calming breath, and about the blue of the water, which reaches something in us that long predates language, some cellular memory of safety and coolness and depth. But perhaps part of it is simpler than any theory. Perhaps what we feel when we watch the jellyfish drift is the recognition of something we have forgotten. A way of being in the world that requires no effort, no performance, no maintenance of self. A way of moving through time that asks nothing but presence and responds to everything with the same quiet, yielding grace. You do not have to watch a jellyfish to feel this. You can simply remember it. You can simply imagine, here in the dark behind your closed eyes, that long translucent bell drifting through blue water, pulsing with the slow patience of something that has been practicing this for 500 million years. 500 million years of opening and closing, of drifting and yielding, of existing without destination or memory or worry, in the full and perfect sensation of right now. That is not nothing. That is, in many ways, everything. Let your breath find its own pace now, the way it always does when you stop trying to direct it. Let it become like the pulse of the jellyfish, a soft and natural rhythm that belongs to your body, not to your will, not to your effort, but to some older and quieter part of you that has always known how to breathe, how to rest, how to be carried. The ocean, somewhere very far from here, is moving in its slow, enormous patterns, its deep currents circling the planet with a patience that makes centuries feel like moments. Somewhere in that water, jellyfish are drifting. They are drifting right now while you lie still, while the night holds its breath around you, while your thoughts grow softer and further apart like stars seen through slowly closing eyes. They are drifting in water as old as the world, in darkness so deep and blue it has no opposite, pulsing gently, feeling the pressure of the water against them, registering the faint shift of a current, turning slowly, trailing their soft arms behind them, needing nothing, fearing nothing, carrying nothing forward from the moment that has just passed into the moment that is arriving now. Arriving so softly you might not notice it until you are already inside it, already held. And in this moment, in this room, in this body that is mostly water and breath, and the accumulated warmth of a whole long living day, you too are being carried through the quiet dark of a night that asks nothing of you but this gentle, surrendered floating, this soft and effortless drifting toward a rest that is already even now beginning to receive you. The jellyfish does not know it is beautiful, and the current does not know it is kind, and somewhere between those two quiet unknowings the world continues its slow and patient turning, holding everything that drifts within it with a tenderness that requires no name. And so our gentle drift through the deep has come to a close, carried along by creatures made mostly of water and wonder, pulsing quietly through the dark ocean like soft lanterns in the night. If you find yourself still awake, the next chapter waits whenever you are ready. But for now, let your breathing slow, let your thoughts grow still and wide as the sea. Sleep well, dear one. You are safe and deeply loved. Good night.